All right, class, do we have any questions on 5, 6, 7, 8, or 12 before we move on? Is it all kind of okay? So like I said, it's mostly the first page of the test. Do you think the first page of the test is going to be reasonable?
It's gonna be light. Light work.
Good. So I think we're going to need to practice that equivalent form that I was showing you on that last, 2 problems ago. So I may throw a question at you like that. It's not in the homework, at least not enough. And so I may make up a few problems here and there as starters or in our Avid notes or something like that. Okay, so the next thing that we're going to do is we're going to review special right triangles. And you guys did learn about these in Math 2. And so, but in this class, we're going to use them in a way to find values on something that we call the unit circle. And that's when you have triangles with a hypotenuse of 1. And I'll explain to you guys next time how a hypotenuse on a triangle, being 1, creates a unit circle, or a circle with a radius of 1. Okay? So anyway, we're going to talk about these special relationships. This is how you learned it in Math 2. And the worksheet kind of builds into how to convert this into Math 3. I'm just going to show you guys because we were gone Monday, we're a little behind, so I'm just going to show you guys what you need to know to alleviate confusion. Okay? So there are a few things you need to remember. And so I'm going to write down some numbers here. Okay? In our triangles, there are 3 special angles that you need to remember. What are the 3 special angles, do you think? 30, 60, 90, and which one? 45, 45, 90. Okay, so I'm going to use the 30. Okay. I'm going to look at the 60. And I'm going to look at the 45 because they all have 90s. Is that correct? Okay, so I want to order those. I want to put them in order, just the 3 numbers, in order from least to greatest. Okay, which one is the smallest of the 3 special angles? Okay, wait, angles, that's 30? 30. Okay. Okay, so 30 is the smallest. Okay. Which one is the largest of those 3 angles? 90. Okay, so that's not one of the 3, but I'll put that down also. So 90 is the largest. Okay. Put it over here. Okay, and so what is the second smallest?
60.
45. Okay, so what should I call that one? Medium? Okay. And then what is the second largest? 60. And what should I call that one? Should I just call it like large and this is largest? Sure. Okay. So really you guys are always going to remember this 90. Okay? That's why these 3 are the ones I really want to focus on because these are the ones that students get confused with the most. Okay. So I'm also going to grab my worksheet. And I want to look at that and see what the problems are in there. Let's see, where did I put my binder? Oh, here's mine. Okay. So on the back side of that worksheet, I may have taken mine out of here. I had one yesterday. What did I do with it? Might have given it to a student. Someone who needed it more than me. Let's see. I'm going to borrow one of these. Okay. Oh yeah, this is the one I wrote in. Okay. So I want to complete numbers 15, 16, and 17 with you. Okay. And I'm going to complete it in a copy that doesn't have any writing in it. And then I'm going to show you 3, maybe 4 if we want to count the 90, important ratios that we're going to remember. Because I don't remember a lot of things, but there are 3 ratios that I'm going to remember. And I'm going to show you guys how to derive them right now. Okay? So we're going to look at, everybody turn to the back side of worksheet 1. We're going to do, right now, numbers 15, 16, and 17 together. And you're going to see that there are going to be 3 and only 3 ratios that appear repeatedly in this problem. See how many answers we have? 3, 3, 3. We have 9 solutions. When they're all reduced, you're going to see that when I reduce them all, they're all going to reduce to the same ratios over and over again. The only ones that are different are these tangent ones. These ones might be a little different. But you're going to notice some very similar ratios reappearing. Okay? So, let's see. I have first the sine 30. So when I'm looking at the 30 triangle, I need to label my 3 sides. My opposite, my adjacent, my hypotenuse. Okay? Joel, can you tell me what this one is called? The side with the A?
Opposite.
Opposite. Okay. And what is this side called?
Adjacent.
Adjacent. And then what's that one called?
Hypotenuse.
Hypotenuse. Where did I put my red pen? Sorry, I like to use lots of colors when I use the board, and I know I don't draw on the board very much anymore. Got lazy. I used to sitting down on the job. Dang. Let's see. All right, and hypotenuse. All right, so using this triangle here, I want to complete my ratios. Okay? Ayana, can you tell me what the ratio for sine 30 is going to be?
Sum is over each sum A over 2A.
A over 2A. Excellent. Oh, I dropped my pen. A over 2A. Good. And then I need to reduce that. What do I get when I reduce it, class? What do I get when I reduce it? Ah, well, the common factor is A.
You get
So-
1/2.
I get 1/2.
Oh.
So that's my first reduced ratio. I'm telling you it's going to reappear. We're going to see it again. Okay? All right, now I need a cosine of 30. Nick, can you help me get that one, please? Cosine 30.
Oh, wait, no, A over 2A. Is that right?
For cosine 30? Cosine is the what over the what?
Opposite over hypotenuse.
No, that is sine.
Adjacent over hypotenuse.
Adjacent over hypotenuse. So what's our adjacent?
A root 3 over
A root 3 over what?
2A.
Over 2A. And what do I get when I reduce that one? Root 3 over 2. And I'm telling you that this ratio is going to reappear. Okay? All right, and then I need tangent of 30. This one doesn't reappear, but its characteristics do. Okay? Alex, can you tell me what tangent of 30 is going to be?
A over A square root 3.
A over A root 3.
Yeah.
And then what do I get, class, when I reduce that?
1 over square.
1 over. Okay, so let me grab my other pen. So this one does not repeat, but it's still good. Okay, because its characteristics repeat. All right, now we're going to do sine 60. I could use that same triangle, and that's why they didn't draw another one for us. But I am going to redraw the triangle, okay? So I'm going to draw this side here. I know the side opposite the 60 is A root 3 from Math 2. Okay, I know that the hypotenuse is still 2A. Okay, this is the opposite here. Okay. And then my adjacent here is now the one opposite the 30. So that's going to be 30, so this must be A. Okay? So now I want to find sine 60. Okay? And let's see, Haley, can you help me find that one? What is sine of 60 using that special right triangle?
Is it the same one?
So I'm using this one now, the 60.
A root 3 over 2A.
A root 3 over 2A. And what do I get when I reduce that?
Root 3 over 2.
Ah, didn't I say, guys, that we were going to have a repeat? Did I get a repeat value?
Yeah.
Yeah. Bam, bam. And that's because cosine and sine have a relationship. Okay? Come from the same triangle. All right, cosine of 60. Alex, can you help me with that one?
It's A over 2A.
A over 2A. Excellent. What do I get when I reduce it?
Half.
1/2. And class, didn't I say that one would repeat? I was right. I am so smart.
So smart.
Love it. Don't you love being smart?
Hashtag so smart.
Yes. Okay. Tangent 60. Callie, can you help me with that one?
A root 3 over A.
A root 3 over A. Good. And class, what do I get when I reduce that one? Root 3? Good. So I said that that one wouldn't repeat, but the characteristics would. Isn't it root 3 the same as root 3 over 1? So aren't those kind of similar? Excellent. Okay, now you're going to see a new ratio appear for the sine and cosine, but you're going to see a repeat occur in this column. It's going to be a little different. Okay, so here we go. 45.
Can you pick which one? Doesn't matter.
It doesn't matter which 45 you pick, that's correct. Okay, so I need to find the sine of 45. Okay. Corral, can you help me find the sine of 45?
It would be A over A squared.
Root what?
2.
2. Very good. And what do I get when I reduce it, class?
1.
1 over root 2. Now, in most textbooks, you're going to see that they rewrite it this way. Root 2 over 2. And I'm going to show you guys why in a few minutes, okay? When we start comparing these special ratios. Okay, so now I need another one. Let's see here. Eric, can you help me with cosine 45?
It's A over A square root 2.
Perfect. A over A, root 2. Uh-oh, isn't that one?
It's the same.
It's the same. Okay, so it showed up again. They're the same problem this time. And now I need tangent of 45. Abby, can you help me with that one?
It's gonna be A over A.
A over A, love it. Okay, and what's A over A, class? 1. So that one doesn't repeat, but it's a pretty easy one, huh? I love that one. That's my favorite, kind of. Some days it's my favorite, some days it's my least favorite. I'll explain to you when it's my least favorite. Okay, so there are 3 ratios that I need you guys to remember. Which 3 do you think I'm going to want you to remember? Root 3 over 2. Okay, there's another one we're going to need to remember. One only showed up one time, so I don't know if I love that one. I'm going to like it a lot, but 1/2. Love it. Okay, there's one more. 1 over root 2. Okay, now I am going to use the root 2 over 2 for a purpose. I'm going to explain that in a moment, okay? So, what I'm going to do right now is I'm going to write those 3 values down. I want to put them in order from least to greatest. Okay, least to greatest. So this can be kind of difficult, and this is why I like the root 2 in the numerator. Okay, I'm going to explain why. Okay, so I'm going to write my ratios down. I'm not putting them in any particular order. I want to figure out which one is the smallest, which one is the biggest, and which one goes in the middle. Okay, so I have root 3 over 2. I'm going to have the root 2 over 2, and then I have a 1 over 2. And sometimes it's hard for us to remember how to put fractions in order. Okay, so I'm going to give you guys a little hint that'll help make it a little easier to visualize. This one is missing something that the other two have. What is it missing?
A root.
It's missing a root. Is the square root of 1 still 1? Yes. So now I want you to take a moment and think about it. Which of these three ratios is the smallest? Okay, so these are our three ratios. We're going to put them in order from least to greatest. What is the smallest ratio? 1/2. Good. Anytime the denominators are all the same in a ratio, it depends on the numerator. And so the smaller the numerator, the smaller the ratio. So this is the smallest. Which one is the largest? Root 3 over 2. Which means that the root 2 over 2 is the one in the middle. Okay, so we are going to learn about triangles where the hypotenuse is 1. Okay? So I'm going to draw them here. I'm going to draw my ratios here with these ones in a moment. Let me erase this part. Okay. Okay. So I'm going to draw 3 triangles. 1. Well, that one looks not like the one I wanted. Okay, I'm going to try again. Okay, I want the smallest angle. The smallest angle is 30, right? Okay, it's okay. It doesn't have to be drawn to scale.
Where are we supposed to draw?
You can draw them anywhere. Or you can just watch for now. Okay, so there are 3 triangles that we're going to remember. The 3 angles are those angles on the bottom. Okay, so if this is the smallest, what do you think that smallest angle is going to be? We only have to remember these 3 because they all have 90, right? We don't have to remember that one. What's this one? 30. I'm going to tell you that the smallest angle is always opposite the smallest side, or in this case, the smallest ratio. Okay? So when this 90, when the hypotenuse is 1, this side here will always be 1/2. Because that is our smallest ratio. So I'm going to do the next one. 45. When the hypotenuse is 1, okay, this becomes our middle side, okay? What ratio do you think will always be opposite the 45? Look at our ratios. There's only 3 possibilities. We already used this one. Think it's going to be the largest one or the medium one? The medium one. So the medium one is root 2 over 2. Okay. And then I still don't like the way that one turned out. Okay. So this is my last one. Okay. Still don't like it. Here, I'll drop it here. Okay. So now I need my last angle. What's my last angle going to be? My largest of my 3 special angles. 60. Okay, and so this is the biggest of the 3. So what ratio do you think will be opposite the 60 every time?
Root 3/2.
Root 3/2. And it kind of goes back to that worksheet we just did. Okay? Sine is the opposite over the hypotenuse. So sine of 30 would be 1/2 over 1, which is 1/2. Sine of 60 would be the opposite over the hypotenuse. Well, if the hypotenuse 1 for the 60, that would be root 3/2 over 1. Hang on, guys. Niebus. Hi. Okay. 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 Okay, good to know. Okay, thank you so much. Sit back. Okay, guys. So, I don't have those triangles perfectly memorized. What I do have is these numbers and those ratios, okay? So the smallest angle is always opposite the smallest ratio. What was the smallest ratio? 1/2. So this is always going to go on the opposite of the 30. The medium is always opposite the medium ratio. What is the medium ratio? Root 2/2. And my largest angle is 60. It's always opposite my largest ratio. And what's that one going to be? Okay? And then the 90 is going to be opposite what? What was it in all of these ones? 1. Okay? So that's when the hypotenuse is 1. Okay. Let's fill in the other sides of the triangle, because sometimes I have to do cosine of 30. So if this is 30, what's this angle? 60. And what's always opposite the 60? Nope. What's opposite 60? Root 3/2. Okay? If this is 45, then this is what? 45. And what's always opposite the 45? Root 2/2. Good. Okay, if this one is 60, this one is 30. And what's always opposite the 30? 1/2. So you end up with 3 special triangles. I've tried multiple ways to remember them. For me, this is the best way because I remember that rule from Math 2. Opposite side is, or the smallest side is always opposite the smallest angle. And the largest side is always opposite the largest angle. And so then I just have to remember 1/2, 2/2, 3/2 with the square root in the numerator. Okay, so I can remember little things like that. Okay, so why did I show you guys that? Because on the next part of your worksheet, we are going to be asked to fill them in when the hypotenuse is 1. Okay, so let's do these together. Okay, so for number 18, I need to know what side or what value is always opposite the 30. Ayana, can you tell me what's always opposite the 30? No, the side length. It's not root 2/2. Root 2/2 is not, what was it? 1/2. 1/2 is our smallest ratio. It's always opposite the smallest angle. Excellent. John, can you tell us what's going to be opposite the 60? Okay, so look at the notes we just took. The largest angle is 60. What ratio is always opposite the largest angle? Well, this one is the largest, so you're right. This one is the very largest. But of the 3 special angles, 30, 60, and 45, this is the largest. And it's always opposite a specific ratio. Yes. Root 3/2 is the largest ratio. It is always opposite the largest angle. Okay? Nick, can you tell me what is opposite the 45?
2A.
No. There's only 3 ratios you have to remember, and none of them have an A in it. Very good. Okay, good. Kyle, can you tell me what's going to be opposite the 45?
Root 2 over 2.
Root 2 over 2. Good. All right, so we're going to do it again. And now we're going to find coordinate values. And I'm probably going to call on Ayana again because she's on her phone. Okay, so if I see you guys on your phone, that's why I keep calling on you over and over and over again. Because I have to make sure you're paying attention. Okay? All right. I'm going to erase this just because I'm going to move my paper up. And I want to be able to see it. Okay, so this might look a little bit harder, but it's the exact same thing that we just did. It's developing this idea of a unit circle. Doesn't this kind of resemble part of a circle? Kind of, sort of? Not really? It should look like a quarter of a circle. Okay? It's a quarter of a circle. Okay. So, I'm going to label the triangle that's within the circle. Alex, can you tell me what side is always opposite the 30?
Adjacent.
No. What ratio, what side length is always opposite the 30? There's only 3 you have to remember.
Sorry, say that again?
There's only 3 ratios you need to remember. Which one is always opposite the 30? 1/2. Good. And if the vertical side, is that an X value or a Y value when it's vertical?
Y.
It's a Y, so that is the Y coordinate. Because whenever you're looking at a point on a graph,
It's how high?
it's how high. Y is always how high. Okay? Good. All right. And Zach Z, can you tell me what is always opposite the 45?
Root 2 over 2.
Root 2 over 2. And is that an X coordinate or a Y coordinate?
I'm gonna say Y.
It's a Y, because again, it's the height. It's the vertical. Okay? Excellent. And then I need another one here. Okay? Okay, so I need to figure out what this one's going to be. Ayana, can you tell me what's always opposite the 60? What was over 2?
1 over.
It's not 1 over 2 because that's the smallest ratio. And it's the largest ratio is always opposite the largest angle.
3 over 2.
Root 3 over 2. And is that an X coordinate or a Y coordinate? It is a Y coordinate. Okay, so now I have to figure out the X coordinates on all of them. The opposites, in my opinion, are always the easiest because I can visualize that. Okay, Eric, can you tell me in this one, if this is a 30, what is that angle going to be? 60. And so if this is 60, what is always opposite the 60? Root 3 over 2. So what is my X coordinate?
Root 3 over 2.
Perfect. Okay. Excellent. And then Connor, if this is 45, what's this one?
45.
45, and what's always opposite the 45?
Root 2 over 2.
Root 2 over 2, and so what's the X coordinate?
1, 2 over 2.
Perfect. Okay. And then Anson, if this is 60, what's this one? 30, and what's always opposite the 30? 1/2, and so what is the X coordinate going to be? Perfect. Okay?
Yes.
We will be doing that over and over and over again. Okay. I do have something else I need to show you today, so we're not going to pack up yet. Okay. Period 7 did go through another part of the objective. It's going to be the beginning part of objective 2. We didn't get very far. I don't know how I was able to get farther with them, but lately I have been able to do that. I don't know why. Okay, so you're going to flip to this portion here. I'm going to stop and restart my video.